The issue that we're having with this particular set of dampers is they are not closing off fully when they should be, as well as the outside air dampers are not opening fully as they should be. These both are controlled by an EP, an electro-pneumatic transducer. You guys may want to check out my video on that to get a better understanding of how those function. That EP works in conjunction with the pilot positioner. The issue is going to be with the adjustments on our pilot positioner. And what I'm going to do next is actually command these dampers to where these should be closed. These are the return dampers, and these should be open, being the outside air dampers. So we're going to move those dampers and I'll show you what those look like. Okay, now I'm going to override these dampers open to 100%. And they will be moving. The EP is going to increase the air pressure to them and is going to move these dampers to the open position and should close these dampers. You can see that they are moving. Those of you all who are familiar with pneumatics do know that the pneumatic actuators are generally very slow in a situation like this. We can see that they are now about 50% or so, and we'll give them a moment or so and come back to show exactly what's going on. The dampers have stopped moving. However, we can see that these dampers here are not fully open, and these are clearly not fully closed as they should be. When we're trying to pull in outside air in this system to use for cooling, this little bit of return air that's coming in here is enough to raise that discharge air temperature to where we will lose effective cooling. So what we're going to do now is adjust the pilot positioners to get the dampers in the correct position. One thing that should be noted prior to doing any adjustments is you need to make sure that your actuators are not leaking, and that is a common problem. If you have an actuator that is leaking air, you will get this type of results also. However, these actuators are currently fine. They are not bleeding off air. We do have plenty of air pressure on them. It's just we do have an adjustment problem with these. Better demonstrate what's going on here. You can see the spring on this pilot positioner here. This spring is where we're going to be making our adjustments. You can see that the position of the dampers, you can see that they're open. However, all I have to do is add just a little more pressure here, a little more back pressure, and these dampers will close off fully as they should be. And when I let that pressure back off, that is when the dampers will open slightly. So what I need to do is to adjust the tension on this spring, and the way that I can do that is by moving the spring to the different holes that are in this arm. Let me see if I can get you a better picture. Those different holes there that are in that will represent a different tension on that spring, and that's what we're going to do to adjust these dampers. A pilot positioner works by taking the full line pressure to the positioner. Then there is a control pressure that is also brought to the pilot positioner. That control pressure can be a 0 to 10 psi, 0 to 15. It really depends on the configuration of your pilot positioner. If an actuator is a 0 to 20 psi actuator and a pilot positioner is a 0 to 10 controlled pilot positioner, then 10 pounds of air pressure on the pilot positioner should equal 20 pounds of air pressure on the output side of the positioner going to the actuator. Likewise, if you were to drop that air pressure to 5 psi, the output pressure from the pilot positioner to the actuator would then be 10 psi. The main function of the pilot positioner is to allow a lower air pressure to control a greater air pressure. Here we've made our adjustment to the pilot positioner, and you can see that these dampers are closed off as they should be. We're now going to bring the system back online.